first of all, who here has actually heard of Couchbase and kind of knows what we're up to? So, okay, decent number of people, about a third it looked like, maybe half even. Okay, so this is going to be kind of to whet everyone's appetite going forward. So Couchbase, we have Couchbase Mobile, which is a complete mobile database stack, and I'll talk about what that is. But tonight I'm actually going to focus more, I think, on Couchbase Lite in particular. And this is really the part that I want to have people kind of take away. So first of all, well, there are two key things that I'll talk about. One is having the full stack, which is really nice because it solves a lot of difficult solutions. People were talking about some other things. So I can talk about some of what I perceive as the differences between like Firebase and Realm, which are both great products, but they kind of solve different things. We solve stuff, what I think of as being a lot of the really core problems kind of end-to-end for having data on device and then synchronizing it to a back-end or with other devices. So that consists of, we have Couchbase Server, which is our enterprise class NoSQL database. So who's familiar with NoSQL in terms of databases as opposed to relational? So some people have never, are new to NoSQL entirely, it looks like. So I'll talk a little bit about what that means. And then Couchbase Lite, and the important thing with Couchbase Lite is that, and this confuses people for some reason a little bit, so I'm going to make this as clear as I can. Couchbase Lite can run entirely standalone by itself. It's a full-featured database that you run embedded on device. So on your Android application, you can use Couchbase Lite as a replacement for SQLite, and then have a NoSQL database that you can do search with, or queries with, I should say, that runs entirely by itself if that's all you need. What's really nice is then if you actually need your data to go off device, and especially if you need to synchronize with data between devices, then we have this kind of intermediate layer piece called Sync Gateway that takes care of these problems. And there are a lot of problems with sync. So one of the examples we like to talk about is a customer, General Electric. And General Electric is no small company, right? They have a lot of resources to throw at things. They were trying to build their own synchronization solution. They'd worked on it for 18 months and were getting really frustrated because it still wasn't working. And they came in and talked to us. They had a proof of concept that they managed to crank out in, I think it was 5 days. And they were shipping with Couchbase in 3 months and have been very happy with it. They're long-standing partners of ours. So I know, I kind of, because I come to this from a mobile background, and so I kind of empathize with you know, typically when I was looking at a mobile project, I'm just like, oh, I'll use SQLite because it's there and it's easy. But if you're thinking about anything that's going to actually want to go off device, and actually in a lot of ways I'm going to go through some pieces, and at this point I find working with NoSQL databases and Couchbase in particular is just actually just easier than working with SQLite. And then if you ever do need the ability to go off device, then you have that available for you. So I'm going to skip back past my, so that's kind of the two main points to reiterate, that very easy to use, and the flexibility for when you expand to not leave you hanging. So I'm going to talk really briefly about the different options for storing on standard things. This is getting a little bit into, so very briefly to talk about the difference between a relational system and NoSQL. So in a relational database, which is what SQLite is, which is your standard thing on Android, you typically take something like this. So this is like a kind of user profile, very simple user profile. And you're going to split everything up. You're going to do what they call normalizing the data. So you're splitting it out into different separate tables, right? And the reason, basically, one of the reasons, this right here, you can illustrate a bunch of the reasons why NoSQL started to become popular, is that it's very hard for one thing to scale this kind of thing because you can't split up these tables across different machines easily. because whenever you want to reform this data, you actually have to go back and pull it from all these separate tables. And so if I've got my tables spread across a bunch of machines, and it's hard to know ahead of time where I'm going to be pulling things from, and it's very difficult to do that in a decent manner. And so that's one of the big key points about NoSQL databases. They're really one of the major ones has to do with scalability, and there's other forms of scalability, like the ability to have multiple copies of your database like around the world. So for mobile applications, when you have people that are using your platform around the world, and you want to be locating your data centers close to where they're actually going to be accessing the data for lower lag times, then you want to be able to split up your databases and stuff like that. And traditional databases don't do that very well. They're also not very, they're pretty fragile under changes, so even just making a simple change like adding a field like that, you generally have to do some kind of database migration piece. That's a pain in the neck, and I won't go into why I show that. NoSQL database, so we have what we call a document-oriented database, which means the basic idea is that instead of splitting that all up, is you take connected units of data and you just store them as a lump. So, and in our particular case, we're storing them as JSON, so what you're seeing here is actually kind of the representation, what the representation of this data might look like as it's actually being fed in the database. And JSON makes it really easy to transition from the kinds of objects that you use in your development to the kinds of into how it's stored in the database. And it's also not particularly fragile, so it's very easy to add things to your document and not have it blow up. And further, so again, kind of emphasizing the idea that of what some people call the impedance mismatch, which is that, and actually there's somebody here whose company is about solving this problem. Yeah, so this is exactly when he's talking about ODM, this is what he's talking about, which is solving the issue of taking the data when it's structured in this format and getting it imported into the kind of format that you want to use for your objects. So when you don't, and there are legitimate reasons why you might want relational databases. They do some things better than NoSQL databases. But when you're not dealing with a relational database and you don't need that, it tends to be relatively easy to transition, to make the move from this format of the data into the kinds of objects you're using in development. So I'm actually going to skip by a few of these other things. So that would talk about why things like synchronization are very difficult. And I'm just going to show this video really quick. So this is a side-by-side video from Ryanair. Who's familiar with Ryanair? They're one of the biggest airlines in Europe. So, okay, so they're one of the biggest airlines in Europe. And this was actually a real problem for them because this is their customer-facing, this is their consumer flight booking app. And it was taking people about an average of like 5 minutes to book a flight with this. I actually think it would take me a lot longer, but you'll see whoever's operating this knows what they're doing. They just kind of fly through it. But worse than that, it was also they were ending up because they were using just what's a fairly typical implementation style that you might use if you don't really think about being offline, which they were using REST calls to a back-end system. They were ended up pushing about 80 gigabytes of data a day, and this is going across, of course, across their consumers' data plans. So in Europe, data plans tend to cost a lot. So this is actually not only a poor customer experience in terms of the speed of the app, but it was actually also literally costing their customers money. And so they switched over to Couchbase. So now they've got a bunch of the data on device. What's really nice is they can update the data when they need to by pushing it out. And so they're actually able to reduce the amount of data that they're pushing across a day by more than a factor of 8. And you'll see with the video, hopefully, this kind of speaks for itself. If you can guess which one's using the Couchbase and which one's using the REST calls. If you can't, then, well. So what's great is when you see the little busy wait, of course, that's when it's making the network calls, right? So that's really kind of puts in your face how slow it can be to, and I don't know, I actually don't know what the conditions were that they were using this app under. I assume that they were using it with probably a solid network connection, but of course, you know, you're quite often not guaranteed have anything from good network connection to not so great to none at all. So like I said, kind of the idea just to get everyone's a little bit familiar with this. I don't want to take up the time because we have some really other great presentations tonight.
Okay, so all the data was cached on the device. How much data was how many megabytes?
I actually don't know how many meg is on, yeah. That's, you know, something you can control quite a bit, so. Anyway, I'll be around, and if people want to ask more questions, and we have meetups here actually every month, and we kind of alternate between mobile and server side. So I don't know what our next mobile one will be, but what are you gonna ask though?
Oh, well, you can control it, but based on. Yeah, I know. I'd love to hear it.
Yeah. There's a ton of detail to get into, especially with like sync gateway and the logic and how you pipe route data using sync gateway and how you handle document feeds and all this sort of stuff. So that is, like I say, a very quick introduction to what I've been with the company 6 months and I'm still learning our technology. So there's a lot of depth to it. But a question back there.
This is the question I had at the conference too. So, which is, I understood that if you change the local database in the mobile device, then you get that like you keep a master table and it gets updated no matter when. It just gets updated at the server side. Do you also have that on the reverse direction, like if it is on the cloud side, something gets updated, changes, and then that change gets reflected on the mobile device side?
So the question is about whether basically replicating changes to data is automatic moving from mobile to device to cloud and the reverse. And actually it's a little more complicated than that. It's actually really simple to set up, but what you do is you have a replication capability that takes just a couple lines when to set up on the mobile side. But it's directional, so you actually set up both a push and a pull replication. So if you have both of those set up, then it'll basically go both directions automatically for you.
In this one-hour example, does the mobile device actually use pull replications to keep the seating information up to date while the user is?
So things like presumably, I'm guessing that they change like route information at times and seat information and things like that. And so yeah, that's the kind of data that they would be refreshing more often than other things.
So which also means the Couchbase app actually need network connection to get the make sure the information is updated, right?
So that's it's and for this you're actually going to want to verify everything. So one thing NoSQL databases are not good at is transactional stuff. So when somebody goes to do a final purchase of this, they're going to have a good network connection. They're going to have to go to some sort of transactional system to do the actual buying of things. So you'd want to verify all that the seat was actually open and things like that when you did that. So you know, it would just be like anything. When I buy a ticket online here, is somebody could have bought it out from under me right before I hit OK, and so it's going to be the same sort of thing where you have to verify it at the last step.
Right. So the Couchbase is not completely offline, so it's just probably use less network than the traditional one, but you still need a network in this process, right?
For something like for this kind of an application, of course, when you can't do a purchase offline,
right.
So yeah, and there's just no way around that.
Yeah.
So yeah.
How does this compare with Google Firebase real-time database?
So I'm not an expert in Firebase, I will say that offhand. So I can tell you from what I've looked at, and take this with a grain of salt, The way I kind of characterize it is Firebase is trying to be a platform that's kind of broad, so they offer a lot of things that we don't. But in terms of the database, there's a lot of things around querying and around how you access the information. Firebase is, from what I've looked at, it basically stores everything as sort of one giant document, not a bunch of individual documents. And so you have things like when you pull the information for something, you get that information and the entire subtree of documents under it. So if you structured your data kind of in a particular way, that's what you just end up sucking up this whole thing. And then they have other things where they have persistence in memory. And I was just reading some stuff last night actually that they'll persist some things to disk, but then the way they actually replicate that, anything that you've done afterwards is quite a bit simplified in comparison. So like I said, take that with a grain of salt. I'm not a Firebase expert. I actually like Firebase a lot. I think it's really cool. But there are a lot of issues to look at, particularly around we specialize on the database side. They're a broader platform. So. Okay, I think that actually went longer than I expected. Thanks for the questions. And so who's going?